Okay, so what this is that it's a situation where you can make either the currents go in the same direction, which in this case I have the current going up, and this is the standard definition of current, okay? But the wires can also spin. So when I press this button, what's going to happen is that I'm going to send a current going up both wires. So what I want to see is what's going to happen to the wires when I send that current up. So I send that current up, and when I do that, number one, I've also got a little like magnet down here. The magnet flips out because this is an extremely strong current. And notice that the wires come together. So here's the first observation, is that when you have...
Beat him up. Beat him up, Bert. Violence is the answer.
Cohen, if that was the case.
No, I know that's the case. You've used that to teach me so many times. Who do you think I learned it from?
He is a dead
Okay. So here's the first observation. If the currents are going in the same direction, what do?
Yeah.
Do they attract
Attract.
or repel?
Attract.
Okay. So rule number one with currents, likes attract. Now, that's in contrast to north and south poles of
Or
magnets.
you know every other thing we've seen so far.
Huh?
Or you know every other thing we've seen.
Or everything else you've ever seen, okay? So here's the first thing. Likes, when it comes to currents, attract. Now we have to figure out why. Now, this is gonna be like a four-step process, okay? So, we're gonna start with this current over here, okay? Don't worry about this one. Act like it's not there. Just don't even worry about it. So this current, the current's going to go up. So what's going to be the magnetic field going around this wire? Don't worry about that one. Act like it's not there. So what's it going to do? What am I going to have on this side? X. I'm going to have X's on this side. So I'm going to call this 1. So this is going to be X1, X1, X1. Okay? So this wire over here is going to be exposed to a magnetic field that's going up like this. Over here you're going to have X's and you're going to have dots. This side over here. Current's going this way.
Now if I thumb.
Should be the what?
So now if I
This current
What are we talking about?
is going up, right? So when you have X's on this side, so don't worry about this one.
left hand.
Right hand rule.
There we go.
There we go. My bad, okay? I was using the left hand. Okay, right hand, boom, these are gonna be X's. Okay, so those are gonna be X's from 1, right? Okay, so right hand rule, got X's. Now using the right hand, we're gonna do this properly. Now we're going to use the right hand rule for charged particles and forces. So this current going this way, right, is going to be exposed to a magnetic field that's going into the page. So the force is going to be going to the left. Okay? So I2 is going to feel a force going in this direction.
Oh my God.
Okay? Cool with that?
Yes.
Good.
Could say that.
Now, we're going to look at what I2 is going to do to this one. So I2 is going this way. So what's going to happen over here? What are you going to have? You're going to have O's.
Gasp.
Okay? So I'm going to have O's over here. So this is from the second wire, right?
I don't know.
Now if you do the right hand rule again, what are you going to have? Current's going to be going up. right? The magnetic field is going to be coming out of the page like this.
Force goes
So the force is going to be directed
To the right.
to the right. So this is why,
Oh, it's because the forces are good.
Yeah, exactly.
Are we allowed to get up and move during the test? Like,
I don't care.
You don't care?
I don't care. So this is why
Yeah, that's
the wires attract each other, because both currents are creating magnetic fields that cause the forces to come inward. Makes sense? Okay. Now I got to rewire it. So give me a second. Rewire it. You got to take stuff off. Hold up here. Check the wiring diagram.
This was my seat.
I bet you they fly away. And then catch fire. Find out.
It explodes.
I want to break free.
That's what that was.
Wrong song. I'm singing Lenny Kravitz. Come on. Get it together. God, I love some Korean.
Fire song.
My theme song. My theme song.
Oh, I'll flip the arrow around for a visual. Okay. Ooh, fancy. So now when I do this, oddly enough, they repel. Okay? Now, we're going to go through the same thought process again. So the only difference, I'm just going to start over. Now, that way we can make the comparisons. So I got this one on the left going
The force.
Which means they'll.
up,
Which means they'll. Right now.
and I got this one going down. Okay, so let's start with this one. So current's going up, or excuse me, current's going down, so what's this one going to experience? This one is going to experience X's or dots? Dots? Everybody cool, right? Current's going down, coming out like this. So this is going to experience dots
Oh, okay, okay.
Oh, I understand it now.
from 1, right?
I'm one.
Locked in.
Yeah.
So
I'm still lost.
now, this current separately, now we're going to use the right-hand rule separately. This current's going up, right? But the magnetic field is going out. So it's going to experience a force going to the
Right.
right. This is going to experience a force like this. Right? Now, we'll repeat the process. Now focus on this one. When this one creates a magnetic field, what's this going to feel? So this is going out like this. This is going to be O's. Cool. So that's 2, 2, 2, right? So that's from that one. So the current's going to be going down.
Because wait, this one.
Yeah, this one's tough to do. Because the currents are going to be going down. The magnetic field is going to be going
Out.
out. So the force is going to be pushing it
Left.
Wait a second, wait, what?
Left. That's.
This is that way. Is it
to the left.
down?
Right? Because the current's going down. The magnetic field is going out. Okay, so here's my hand. It's just cramped up literally. So this is why these repel. So this is kind of the oxymoron of what you've always been learned in terms of, opposites attract and likes repel. When you have wires, opposites
Shoot yourself in the face.
repel,
Turn that gun upside down and shoot yourself in the face.
and
What?
the same current attracts. Okay? Got it? Okay, back we go.